Hello everybody, Mr. Gazda here, 683, homework review for astronomy. First one here is moon phases, so here we go. Draw the moon would look to an observer on Earth at each of these locations. Location F. Okay, I'm going to draw it in there. So first thing you want to do is turn your paper like this. Okay, draw Fred on there, below location F. Okay, what does he see? Draw on the line that shows that what he sees. And I can go right through there and right through there. Okay, so that line looks like this. Okay, what does he see? He sees mostly dark, left side dark. Mostly dark, left side dark. So so what should look like this. I'm gonna do it in black actually. Mostly dark, left side dark. Kind of like this here. Color that in. Okay. It may not be the best representation, but it's a crescent, and you see the right side here. Sorry about that if that's not that clear. Okay. G. Location G. Turn my paper like this. Put Fred on there again, directly underneath G. He's looking into the paper. See the back of his head. Draw in the line that he sees that. So now he sees mostly light, left side dark. I keep that in my head. Mostly light, left side dark. Mostly light, left side. So I'm always drawing a crescent shape here. I'm going to try to do it better this time. Like that. Okay, and then I do this. Okay, so mostly light, left side dark. Okay. Here we go. And then E. Let's see. E is here. So I want to go like this. I'm going to draw Fred right there, looking up at E. Draw the line in there. Mostly dark. Right side dark. Mostly dark, right side dark. And mostly dark, right side dark. Here's my crescent shape. Color this in. Coloring that in. That's what it would look like. And then location B. And you got to turn the paper over. This can draw some people crazy sometimes when they don't do that. Draw Fred. Draw what you see for B. Half lit up, half dark, left side dark, half and half, left side dark, half and half, left side dark. So I remember half and half, left side dark. Okay, there we go. So that's what they should look like basically. And then write the name of the moon phase next to each. So I'm going to start here by writing the names in like this. I'll leave the first part blank, and this is a crescent moon. This will be a something gibbous moon. This will be another crescent moon. We'll fill in this, okay? And this I'm going to say it's going to be first quarter or third quarter. And this is actually going to be first quarter. I'll use the first base analogy. You're on home plate. First base is on the right. First base is white, lit up on the right. So first quarter. That's first quarter is the name of that phase. Now this one, crescent, waxing or waning. Waxing or it's lit up on the right side. Lit up on the right side. So if we want to go back to our alphabet method, Bill Burka method, thank you Bill Burka, look at the, right, it's either waxing or waning, so it's either going to be a waxing crescent or a waning crescent, okay? And then waxing, X is here. So if it's lit up on the right, it's waxing. If it's lit up on the left, it's waning. See how that works? So this is lit up on the right, therefore if I go here, lit up on the right, X waxing. It's going to be a waxing crescent moon. Okay? This, gibbous moon, it's lit up on the right, same basic idea. Same waxing or waning gibbous, lit up on the right, waxing gibbous. Waxing gibbous. Okay? And then crescent moon here is lit up on the left, and if I go by alphabet method, N is on the left, therefore it's going to be a waning crescent. That method works great. I would really like to thank Bill Burka, yet again, a former student of mine, for coming up with that. I really, really like it. Okay? There we go. So on to the back. Here we go. You will need a reference table for this. Absolutely. So, by which process do stars convert mass into great amounts of energy? Ladies and gentlemen, know this. Nuclear fusion occurs in stars. The sun is a star. Nuclear fusion, two atoms fused together, creates a new element, heavier element, and gives off lots of energy. That's the source of the energy in stars, and that is should be choice number 1. Okay, that should be choice number 1. 3, diagram below, the present day celestial objects labeled A. Okay, so time is going by, Big Bang, these things are moving apart. These are spiral galaxies, choice 3, spiral galaxies. 7, the Foucault Pendulum provides evidence of Earth's, ladies and gentlemen. I want to point this out. We see these questions a lot. Okay, the Foucault Pendulum and the Coriolis Effect, that's the curving of winds on Earth. Okay, how winds don't go straight from the equator to the poles or vice versa. They're kind of curved to the right or to the left. Both of these are evidence that Earth rotates. Earth rotates. Now, there's a little more to this question because it's evidence of Earth's not 1 or 2, because that's revolution. That's around the sun. So rotation on its axis, geocentric versus heliocentric. Geocentric, Earth in the center of the solar system. Not true. Okay, we used to think that, but we know now that that's not true. Heliocentric, helio means sun. So this is correct. We are in a heliocentric solar system. So 7 should be 4. 6, compared to the other planets, Jupiter, Saturn, Neptune. Okay, I have a reference table somewhere. Here we go. You want to look at we're looking at shorter periods of rotation, eccentricities, densities. Well, what's it looking? Greater densities, they don't. They have lower densities, so it's not that. That's not choice 4. Greater eccentricities. Their eccentricities here are actually quite low, so it's not 3 either. Shorter periods of revolution. Period of revolution. These are much longer. The further out you go, the longer the path, the slower they go, much longer. So it's not that. It's going to be 1. Shorter periods of rotation. So to spin once, their rotation here is much shorter, okay? Much shorter. You know, Earth is that 1 day, Mars is close to that. These are much longer, so they're going to be shorter. So 6 should be 1. Okay. And then this is question 1 here. Diagram shows a heavy back and forth. This is doesn't say the name here. This is a Foucault pendulum. And this device provides evidence that 1, Earth rotates. Know that for sure. Compared to the terrestrial planets, the Jovian planets have. These are the outer 4 planets. Outer, okay? These are the gas giants. Outer. Terrestrial are the inner. They're Earth-like. That means terrestrial means Earth. Earth-like, the inner 4. You need to know that or else you have trouble answering this question. But once you know that, you can look up on the reference table. So the Jovian planets have, you would look up here. You got to look here and check each one off. Jovian planets are much larger. They have lower average densities. They have faster rates of rotation. They spin faster. So the answer should be 4. 2 should be 4. Okay. Coriolis Effect. As I said, here we go. Both of those. Evidence Earth rotates. Therefore, as a result of Earth's rotation on its axis, 10 is also 4. 6. Where has the process of nuclear fusion been occurring for over 4 billion years? Okay, here we go. Nuclear fusion is in stars also. And our sun is a star, a main sequence star. And the sun, that is the source of the energy that the sun gives off. Therefore, 6 should be 4. And then this is really kind of wordy now. Just dig this. If the average distance between Earth and the sun were doubled, okay, so it's further away, Earth, sun, further away. Therefore, it's going to have less gravitational effect between the sun and the Earth. What changes would occur to the sun's gravitational pull and Earth's period of revolution? So now Earth is further away. It's going to have less gravity. It's going to travel slower and have a much longer path to travel. The way that the outside lane of the running track has a much longer path to travel. Answer here. You really got to read. This can be confusing. You may really know this and still have to read through this a few times to get it right. Gravitational pull would decrease. That's true. It would decrease. So I want that. You see this one? It's not this one. There will not be more gravity. It'll be less because they're further apart. So let's cross out 3 and 4 right there. The period of revolution, how long it takes to go once around the sun, would increase. Longer path and slower speed. So it's going to be choice 1. So hopefully that helped. Hopefully you got a lot of those right. And what you didn't, hopefully this is clarifying a bit. But, so this is 683 for Mr. Gazza, all the fine folks at Gazdoni Productions. Thanks for watching.